How does the shape of a stream change over time? So you'll notice we skipped over a bunch of slides in the PowerPoint. That's just for your extra knowledge. That's stuff I would go over in class with you. But the majority of the ones throughout here, you can see this is an old stream. Anything with a waterfall is a young stream. But now we're going to go into how the shape of the stream changes over time. So this is a very important diagram. What it's showing you is a stream and how the water flows in the stream. Now, first thing I'm going to look at is right here. Number 2, C and D. So here you see the water flowing. Now the water is actually going to flow at different speeds at different parts of the stream. Water flows the fastest when it's going straight in the middle, just below the surface. And the reason for that is you have the water touching the stream bed. That water is going to go slower because of friction. So it's going to slow down. So anywhere around the stream bed, the bottom and the sides is going to go slower. And the water on the surface is going to go slightly slower because of friction with the air. So just below the surface, in the middle, is your fastest water. Now, the water doesn't know how the stream bed is changing. So if I have the fastest water here, what's going to happen is as it goes downstream, it's going to continue going straight and then hit the outside. So now the fastest water is hitting the outside of the river. All right, so here's the fastest velocity here. Then you can see on the turn, the fastest velocity is now over here. And that brings you back to over here, number 1. So the was probably straight up here. The fastest water comes down, hits the turn, and you got the fastest water on the outside. So the outside of the turn, or the curve, or the meander, is always the fastest water. The inside is always the slowest water. So what happens, and remember, that's only on a turn. What happens is, if we went back to our chart about water speed, you're going to have erosion on the outside and deposition on the inside, because the fastest water is going here. It's going to pick up the larger particles. The slowest water is here, and that's going to deposit or drop the particles. So that's what we're showing here. More erosion, more deposition. Okay, erosion, deposition. Water on the inside of the curve moves slower, dropping off the sediment. Water on the outside of the curve is going faster. And that's what all of these are showing you. So here we have our meanders. Outside, erosion. Inside, deposition. All right, same thing. Outside, erosion. Inside, deposition. That's what's going on throughout all these. Wherever the curve is, the outside of the curve is going to be erosion, the inside is going to be deposition. And that brings us here. So now you don't have to worry about the terms, but you got to worry about what's going on. So the water is flowing this way. Erosion, 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 erosion. So over time, if I have erosion here and here, and deposition here and here, what's going to happen is these are going to meet up. These are going to meet up right here. So if that takes place, sooner or later, these two are going to meet up. And if they meet up, you then have the stream going this way, and you have that oxbow lake, which is right here. You can see it. Okay? Deposition, erosion, deposition, erosion. Sooner or later, these are going to meet up. And then you have that oxbow lake right there. Stream goes by, oxbow lake stays there. Sometimes they stay if they're big enough. Here's an excellent diagram of it. Forming it together. Oxbow lake ends up